everyone, welcome back to the Big Data Show. Today we are going to discuss Kafka broker. In the previous session, we have seen that for scaling horizontally, Kafka divides the topic into multiple partitions, and each partitions of Kafka topic can be placed on different machines. These different machines technically are called Kafka brokers. So I hope in a very layman terms, you have understood what is a Kafka broker. Let's try to go deep into that. Okay. So we have seen in our previous sessions, if you have not watched the previous sessions, I am just tagging the link here, or you can even watch the second video of this playlist, or third video of this playlist, like the previous video. So we have seen that one topic can be divided into multiple partitions. And what is a partition? Partition is nothing but an ordered sequence of event. And each number, each sequence, this number is called offset, right? So we have seen this. Okay. So I have also told you in the last session that each partitions may live on different server or different machines. And these servers are called as Kafka brokers. Combinations of different Kafka brokers is actually called as Kafka clusters. More than one brokers will be termed as Kafka clusters. Okay, and a single Kafka cluster is called as a Kafka broker. Perfect. Okay, and so for a very simple Kafka clusters can have only one broker, but company like Amazon, Flipkart, Netflix uses more than 100 number of brokers. And I was actually fortunate enough to work more than 50 number of brokers in one of my project. And that was really a challenging project and very tier one project for me. That was the item fraud detections with one of the e-commerce company. Cool. So till now we have got that what is a Kafka broker? Kafka broker is nothing but a machines where one of the partitions of particular Kafka topic can be present. And combination of all these brokers is called as Kafka clusters. Perfect. Okay. So, and we in the last sessions, we have also seen that data in Kafka is actually stored on the disk. And we have learned that Kafka topic is partitions. So let's try saying brokers logically in a diagram. Okay. So let's suppose I'm having one topic with the name topic A, and I'm having three partitions. So you can see here, if I'm having three machines, one of the partitions of topic A can be present on one broker. Another partition of topic A will be present on another broker, and the last partitions or another partitions of topic A will be present on another broker. And there is no relationship between the partition number and broker ID. Like if you can see for topic A, I am having three partitions, 0, 1, and 2. This 0 is there on broker 1, but this partition 1, which is actually partition 2, is there on broker 3. This partition 3 is there on broker 2. My partition number is starting from 0. So partition 0 denotes actually partition 1, partition 1 denotes partition 2, and partition 2 denotes partition 3. Well and good. And you can see that there is no relationship between these numbers and broker ID. Okay. A broker in cluster is identify a unique numeric ID. It can be 1, 2, 3. It can be 101, 102, 103. It can be anything. Okay. Cool. Okay. We have seen that by dividing the topic into multiple partitions and by keeping the partitions on different machines, Kafka scales horizontally, right? Because if needed, more powerful real-time streaming platforms, and if you want to make your do more parallel work, you can always create more number of partitions. Like you can say 50 number of partitions as 50 when you are creating Kafka topics. So 50 partitions of your Kafka topic will lie on 50 different machines, right? Can lie on different machines. And in this way, you can always horizontally scale it, right? So number of partitions in Kafka is a design time decision. Whenever you are creating Kafka topic, you will define the number of partitions. And each partition of Kafka topic can actually be present on different machine, which is nothing but a Kafka brokers, right? This we have seen. Now let's try to see. This we have already understood just now. Each partition of Kafka topic can be placed or kept at different Kafka brokers. This helps Kafka in a load balancing and scalability. Well and good, right? This we have also understood that there is no relationship between Kafka broker ID and partition ID. Okay. This concept, this particular example, I've already made you understood here, right? Right. There is no relationship here. Let's see it again. So topic A can have three partitions: partition 0, partition 1, and partition 2. Partition 1 can be on broker ID 1, and partition 1 can be on broker ID 3. Partition 2 can be on broker ID 2. So there is no relationship between broker ID and partition. Make it very, very clear. Cool. Let's try to recap whatever we have learned till now. So for the first point is a Kafka cluster is composed of multiple brokers, which is nothing but some machines, right? Where these are JVM machines where the Kafka program runs, right? So this is the nothing but some machine in somewhere in the cloud. Let's suppose if you use some cloud-based Kafka managed services, then the data will be stored somewhere, right? If you use Confluent is the commercial provider. They will also keep different machines, right? They will also keep the different machines where they will initiate the JVMs, right? Where the Kafka program will run, right? So Kafka, you can install, this is also open source, you can install, you can manage it, or you can also use some commercial packages. Like Confluent is one of the company which provide the commercial package of Kafka. Like you don't need to manage your Kafka, they will manage for you. You can just buy them. Okay, cool. Each broker is identified by its unique ID. The ID can be 123, 101, 102, 103. Each broker can contain certain topic partitions, right? So in broker ID 101, like can have partition 0 of topic A. Broker ID, broker 2 can have partition 2 of topic A, right? So we have understood this. Cool. So by placing different partitions of Kafka topic on a different machines or server, Kafka at scale is scalability. This we have discussed again, and I'm repeating again and again because this is highly asked in interview. Like how you scale, how can you scale Kafka horizontally, and which factor actually determine scalability? So it is the partition of Kafka topic. Cool. Perfect. A simple Kafka cluster can consist of single Kafka broker or more than 100 Kafka brokers. Well and good. Like I've also told that in production use case, it is not recommended to just have only one brokers. Well, right? So let's try to understand that how does client will actually connect to Kafka broker. So firstly, you have to understand that for connecting to Kafka clusters, which can have multiple brokers, a client application like Kafka client or Apache structure streaming, Apache Flink, Kafka Connect, even Spring Boot, or any other things, which can act like a client of that particular Kafka topic, does not require each and every URL or address of every broker. If you have the address of one or two broker, it is more than enough. So how it will work, like let me help you from the diagram. So Kafka client, the first thing that they will do is to go to one broker. Every broker of Kafka cluster can act as a bootstrap server, which will have information of any other brokers, right? So first step is to talk to one of the broker, which we call the bootstrap servers or bootstrap brokers, and establish the connections and metadata request. From this particular broker, this will give the list of all the broker and it will give all the metadata. After that, Kafka client can talk to any other brokers. So this is the way of communicating. And any broker of Kafka clusters can be act as a bootstrap server. So if someone will ask that what is bootstrap server? So bootstrap servers or brokers, any of the Kafka broker will act as a bootstrap server. Every broker will have informations about the other brokers. Whenever Kafka clients try to connect to that particular server or particular broker, they can connect to any of the machines and they can get the metadata. And once this connection is set up, they can always communicate to any other brokers. Well, but in production use case, it is recommended to at least have two URL or two address of, so let's suppose I'm having 5 brokers in a Kafka clusters. So I will have, for every machines, I will have some URL, right? Like some address, URL 1. And for this, I will have URL 2. This is the address, right? So same way, I will have multiple URL 3, URL 5. So while connecting to Kafka clusters, I don't require the each and every address of every brokers. 1 and 2 is fine. It is recommended to have 2. So let's suppose if 1 is lost, we can always communicate to 2. So it's the same thing I've written. In productions, we should at least have past 2 Kafka broker address. In case 1 is not available, then other will respond to the Kafka connections request, right? It means that Kafka client does not need to be aware of every single hostname or URL. Perfect. Well and good. So same thing I have written it here. Let's try to recap from here. A client application that wants to send or receive message from Kafka clusters may connect to any broker in a Kafka cluster. Every broker in clusters has the metadata about all other broker in the clusters. Well and good. This I've made you understood. Any broker can help the Kafka client to connect to all other brokers, right? Therefore, any broker in the Kafka cluster can be called as a bootstrap server. Perfect. If somebody will ask you what is bootstrap server, you will always able to answer like any of the broker can act as a bootstrap server. This is very, very simple. And what is a broker? Broker is nothing but a machine where one of the partition of Kafka topic can be present, and combination of all these brokers will be called as Kafka clusters. Well and good. Now, I've told you multiple times that scalability of Kafka is determined by the number of partitions of Kafka topics. But there is one more important concept, which is replication factor. Let's try to understand how does Kafka provide replication factor. So, how does Kafka actually provides fault tolerance? And it provides fault tolerance using replication factor. I hope you have got the gist. I got confused with the words. Okay. So, replication factor, what will happen? So let's suppose I'm having one Kafka topic and I'm having 2 partitions. Okay. So I'm having a topic with replication factor 2 and topic has 2 partitions. So it can place one of the partition at one of the broker and another partition and another broker. If I have set replication factor 2, what it can do is to replicate this particular partition to another broker, like topic A partition 1, like this can be replicated here. Same way, this can be replicated here. Topic A partition 0. Let's suppose in some cases, if this is lost, let's suppose if this particular broker is lost, like this broker 102 or broker 2 is lost, you can always serve your program using these 2, right? Because these 2 brokers will always contain your partitions. So that is the benefits of replication factor. And in this way, it is a fault tolerance. In case of some failure of one of the brokers or any broker, as the partitions of Kafka topic is already replicated to another broker, in case of failure, Kafka will be always fault tolerant, like your data will not be lost. Perfect. Now let's try to understand in sync replica. Before that, you will ask me, Ankur, that you have told that there will be replications of the partition of the topic. But how do I determine that where to write? So for this particular topic, I'm having one partition 1, right? And it is placed on broker ID 101. For same topic A, I have another replica which is also placed on partition 102. So if I start writing on Kafka, where my events or messages will be actually written? Will it be written on this particular broker or will it be written on this particular broker? So based on concept of leaders, it will be always written on the leader partitions. So let's suppose if this is called a leader, this is called a leader, and this is called in sync replica. In sync replica. Okay. So this is a leader and this is called in sync replica. What will happen that whenever some data is written, data will be replicated here, and which is very, very fast or near to fast. But data will be always written to the leader partitions. So that is the meaning of ISR. So if somebody will ask you what is in sync replica, then I hope you will able to answer it. This is nothing. But as we set the replication factor, what does Kafka will do? It will replicate the partitions of one broker to another. And there will be always one partition leader chosen for that particular partitions. Like there will be one leader and another will be in sync replica. And data will be always read or always write from the leader partitions, not from ISR. In case of failure, ISR will become leader. I hope this is clear to you. So let's try to revise it. Whatever we have learned, I have tried to move little fast because this is very easy concept to like understand. So in the beginning, we have understood that what is Kafka brokers, and I have told you that in our previous sessions we have read that for scaling the uh, Kafka topic, which is nothing but a log of event, right? Which is nothing but a log of event. Where there will be one event, one, two, three, event one, event two, event three, event four. So actually, for like scaling it horizontally, Kafka topics, this log of events is divided into multiple parts. So let's suppose Kafka topic 1 has 3 partitions. So it will be like partition 1, partition 0, partition 1 and partition 2. It is having 3 partitions. Each partition of this particular Kafka topic can be placed on any of the machines, like one partition at one machine, another partition at another machine, and these machines where this machines is actually called Kafka broker. And what does this machines do? This is nothing but a JV machines where the Kafka program runs on the JVM, right? Java virtual machines. Well and good, right? And combination of multiple broker will be called as a Kafka clusters. Then we have understood that how it is replicated. There is a concept of replication factor, right? So replication factors uh, helps Kafka to provide fault tolerance. In case of some failure of one partitions, one broker, data will be always there because the partition of that particular topic will be replicated to another broker, right? And this provides the fault tolerance in Kafka. So just remember, scalability of the Kafka is provided by the partitioning of topic, whereas fault tolerance of Kafka is provided by replication factor of Kafka. I hope this makes this is clear to you. Then we have also seen what is the concept of bootstrap server. I have told you any Kafka client applications for connecting to different broker with like different machines of Kafka clusters, they don't require to connect to each and every brokers. They can connect to any broker which we can call as bootstrap server, and then that will give you the metadata information of all other brokers. And once this is set up, a Kafka client will start talking to all other brokers. So in production use case, there is no need of passing URL of every broker. Like I'm having five Kafka brokers in my Kafka clusters. I don't need to pass address of each and every brokers. Only 1 and 2 is fine. Usually in productions, you can keep 2 addresses because in case of some failure of one broker, you will have 2, right? This we have understood. Then we have understood the concept of in-sync replica. What is in-sync replica? Like if you set your replication factor, then there will be always one leader partitions where the read and write of Kafka messages will happen, and within some second the data will be replicated to another partitions which can lie on the another Kafka brokers. In case of failure, the in-sync replica can become the leader partitions. I hope these all concepts, this very simple concept is now clear to you, and you will able to understand what is Kafka broker, what is replication factor, what is ISR, and what is bootstrap server. 4 concepts. Let's try meeting in the next video and let's try to understand some more concepts. So we should understand now. We are left with concepts like producers, consumer group, and zookeeper. Once we understood this key concept, then we will move to the module 2, and then we will go and try going more deep into the Kafka. And we will be not only talking the theoretical concept, we will start installing Kafka and actually write some code. So, but I wanted to set up your foundations, so that's why I wanted to at least cover the key concepts. So till now we have covered that what is a Kafka, then we have covered what is event streaming, then we have covered what is event actually, then we have covered what is topic, then we have covered what is partition in topic, then we have covered what is topic partitions, then we have covered uh, brokers, we have covered bootstrap servers, we have covered replication factor, and then we have covered ISR. So we have covered lot of topic now. And I'm also creating lot of problem statement in our community sections. If you go to the community section of my YouTube channel, I'm creating lot of MCQ questions to practice. I will also try providing some of the link in this description of this particular video, but you can always go to the like you search my channel on YouTube, then go to the community section or tab. You will find lot of MCQ problems there. So you can solve all those MCQ problems to be better at the theory. I hope you have learned something. Let's try meeting in the next video and let's try learning some more concepts. Until then, goodbye and keep learning.